Hello, in this video we will go over the different types of triangles based on their side lengths and interior angle. We will also go over the triangle sum theorem and exterior angle theorem. So yeah, this is all about classifying triangles. So a triangle is formed by three segments that is joined by three non-collinear points. Each segment is a side of the triangle and a point where the two sides meet is a vertex. To name a triangle, you list the vertices. So, for example, triangle ABC, triangle BCA, and triangle CAB. So, side lengths has that line. So, sides are line segment AB, line segment BC, and line segment AC. Vertices are these points. So, here's an example of an image, a triangle. And as you can see, this is an example of a side. Side would be length AB. And then the vertices are the capital letters. So you have vertice A, vertice B, vertice C. Okay. So we can classify triangles by their sides or angles. So here on one, we have what's called an equilateral triangle. That means all sides are congruent. And I also want to say if you have an equilateral triangle, you most likely have a 60-60-60 degree angle. So because all sides are congruent, it also means three angles are congruent. And they're most likely going to be 60 degrees, 60. Oh no, for sure they're going to be 60 degrees, 60 degrees, and 60 degrees. Because later on you'll learn that the sum adds up to 180. So did you know that this side faces this angle, and then this side faces this angle, and then this side faces this angle? Okay. Okay, then you have what's called an isosceles triangle, is when you have two sides. And when you have two sides are the same, that means their two angles are congruent. So you also have two congruent angles. Okay. Um, yes, so that's an isosceles triangle. In a scalene, you have no congruent sides and you also have no congruent angles. They're all different. Nothing's the same. That's it. Okay. Equiangular is related to equilateral. They're like the same thing. It just means an equiangular. Oops, where did I go? In an equiangular triangle, all three sides are congruent. That's it. And in isosceles, it just means you have two congruent angles, and you also have two congruent sides. In a acute triangle, three angles are acute. And what is acute? It just means less than 90. Okay. In a right triangle, you have one 90-degree angle, and the rest must be acute. And then in obtuse, you have what is an obtuse angle? So this angle here would be obtuse. Uh, so it just means greater than 90 and less than 180. So an example could be like 120 degrees, right? It's still greater than 90, but less than 180. Okay. The sides of a right triangle and an isosceles triangles have special names. Here on the left, we have a right triangle, we have a leg, and then hypotenuse. And in isosceles, here's an isosceles because these two sides are the same. That means you have an isosceles. Here's a leg, and here's the base. And very important note, every equilateral triangle is an isosceles triangle. So what is an equilateral? All sides are the same, right? Is an isosceles. So that makes sense, right? You have an equilateral, all sides are the same. You have an isosceles, yes, because in isosceles, at least two sides must be congruent. But not every isosceles triangle is equilateral. Okay, that just breaks this point. So yeah, every equilateral triangle is an isosceles, but not every isosceles triangle is equilateral. Okay, on this example, we have this triangle, or we have like three triangles, right? Do you see three triangles? We have side lengths, no angles, and we have vertices. They want us to list a few things. From this image here, they want us to list the equilateral triangle, the isosceles triangle, and the scalene triangle. So let's start with the equilateral. So an equilateral means all sides are congruent. So do you see three triangles? So this could be the first triangle, right? And then this could be the second triangle, and then the third one is the main one, like the main this one right here. So equilateral, I see one. It's the triangle one because all sides are the same. Okay. So how do I label that triangle? Uh, remember we go by vertices, so it's going to be triangle G H J G G. So G J H, or you could also say what else? G triangle G H J. Okay. So G H J or G J H. Okay. What about an isosceles? So in an isosceles, two sides are the same. So I think it's related to triangle two. So if you look at this triangle right here, notice that you see that these two sides are the same, and that's enough to say an isosceles triangle. So I think there's two ways you can describe that triangle. You can label it as triangle G H G. Let's see if that's true. Where's G H. Oh, I see three isosceles. The other one here. Let me use another color. The other triangle I see is the main one. And then I think you can also use this triangle right here. Okay. So yeah, you can express it as triangle GHJ and triangle HJK. Okay. What about a scalene? A scalene is basically when those sides are the same. So I guess the scalene would be the main triangle. This one, right? The big triangle. Because if you look at all the sides, this has a side length of 19, this has a side length of 10. Now be careful, what is the length of GK? 20. See how they're not all the same? So that means you have a scalene. So that could be expressed as triangle GHK. Okay, so yeah, that wraps up for that question. So let's do another example. It says, name each of the following. You have If you have this triangle, you have three triangles, right? Do you see three triangles? You could do this triangle, and then the main triangle is the third one. So number four says names all the acute angles from 0 to 90. So acute is less than 90. So if you just want angles that are less than 90, so angle 40 is less than 90, 58 is less than 90, angle 82 is less than 90, 50, and 32. So that would be, I guess you could say angle R, angle P, and what about angle RQS? RQS. Yeah, you could say RQS and how you can also say angle. Could we say angle Q? Not quite, because angle Q is facing 82 and 90, so we have to be very careful. Uh, we just want this angle right here. If we say angle Q, see how there's two angles between angle Q? So you could say angle RQS, and what else? So we did P, we did 58, and we could also do 40 and 50, but we can't just say angle S. This 40 degrees would be expressed as angle RSQ. RSQ. And then this 50 degrees could be expressed as angle PSQ, right? Okay, so yeah. Number five, it says all obtuse angles. So it has to be greater than 90, but less than 180. Is there any that are obtuse? Well, did you also angle S, this angle right here, because it shares two angles. If you add them up, what's 40 plus 50? Oh no, that's 90. Oh, I see one. This 98. That is greater than 90 but less than 180. So we can't just say Q, it's going to be SQP. SQP. Okay, number six, do you see any right angles? Don't see that box symbol, so uh I do. I mean, it doesn't just because you don't have that box symbol, it just has to be means it has to be equal to 90. Do you see an angle that's exactly made up to 90? Yes, if you add this 40 and this 50, that equals to 90. So that would be expressed as angle RSP. SP. Okay. Number seven, acute. What is acute? It just means less than 90. So there's quite a acute. Uh, oh, they want an acute triangle. Sorry. So they're not asking the angles, they're just talking about the triangle. So how do you describe a triangle? By its vertices. So you're gonna have three vertices because you have three angles in a triangle. So one acute triangle would be triangle RSQ, because this triangle one, right? Why is it RSQ? Is because if you look at all the angles, 58, 40, 82, none of them are none of them are 90 or above, right? They're all acute, they're all different, and they're all less than 90. So one triangle would be triangle RSQ. Okay. What about a right triangle? So they're not asking for the angle, they want an actual triangle. So we know that 40 and 50 add up to 90. So that triangle would be expressed as RSP, right? Angle RSP. Not angle, triangle, right? Triangle R. I always get that confused. RSP. Okay. What about an obtuse triangle? anything that's greater than 90, but less than 180. Yes, this 98 is an obtuse, but I want an actual triangle, so that could be expressed. So how do I express triangle 2? Because that is an obtuse. It would be SQP. Okay, number 10, and an angle complementary to angle QSR. So complementary means equality, right? So an angle complementary to angle QSR would be uh that would be angle. So you have angle QSR plus X equals 90. And if I subtract QSR, QSR. So here, that's triangle one. QSR, that would be QSP. Oh, it would be QSP, right? So if you add up these two angles, they give you 90, right? And that would be an angle. So you can't just say angle S, it would be angle uh, QSP. Okay, number 11, an angle supplementary to triangle RQS, I mean PQS. PQ supplementary means add up to 180. So first, locate where angle PQS is. PQS. PQS. So this one, PQS, that's 98. What? Oh, remember, 180 is like a straight line. So maybe this 82. Yes. So you would be, I guess, angle RQS. RQS. Okay. Okay. Next one. When the sides of a triangle are extended, other angles are formed, right? That makes sense. You have interior. So here's your triangle. If you keep continuing the lines, you have what's called an interior angle, and then you have an exterior angle. So interior, exterior. And this relates to the triangle sum theorem. So in a triangle sum theorem, the sum of a measure of the interior angles of any triangle is 180 degrees. So basically, inside a triangle, if you add up all the angles, all the interior angles, it should add up to 180. That's what the triangle sum theorem means. So here, if you look at this image, you have a triangle and then you have a straight line on point C. And if you add up angle 1, angle 2, and angle 3, they add up to 180. And as you can see, these congruents are not the same. That means angle 2 and angle 3 are not equal, right? And yeah, so angle A, angle B plus angle C adds up to 180. Angle 1 is congruent to angle A. Why? So if you kind of like extend this line, right? Why is angle 1 congruent to angle A? So if you continue this line and then if you continue this line right here could be the transversal, and they're on the opposite side of the transversal. So the reason would be alternate interior. The same thing with angle 3 and angle B. They are congruent because alternate interior. And then if you add up angle A plus angle 2 plus angle B, right? this angle and this angle, they should add up to 180. Okay, let's talk about exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measure of two non-adjacent interior angles. Okay, so here we have this triangle. So angle one is the exterior angle of A and B and are called the remote interior angles. So did you know, here we have this image. Here's angle one, right? Did you know that angle one is equal to the sum of angle A and B? So you could find out what angle one is by adding up these two angles. Could you find it? Could you find angle one in another way? Yes. What would be the other way? Well, if you know this angle right here, and then we don't know what angle one is, right? Or if you knew what angle one is, you could find out with this angle. Because if you add up these two angles, this unknown angle plus angle one, they form a straight line. So yeah, so there's two ways you could figure out angle one. You can set angle one to the sum of these two angles, A and B, or you could say that this angle plus this angle equals 280. Okay, let's talk about corollary to the triangle sum theorem. Corollary to the triangle sum theorem, the acute angles of a right triangle are complementary. Angle A plus angle B equals to 90. That makes sense, right? Because what does the sum have to be? The sum of a triangle of the interior angles should all add up to 180, right? So this angle plus this angle must equal to 90. Could these two angles be the same? Yeah. This could be 45, this could be 45, and then you're left. And when you have two angles that are the same, that means you have two side lengths, which is an isosceles triangle. So if you add up all the interior angles, angle B, angle A, angle B, angle C, they add up to 180. And angle C is 90 because it has that box symbol. And then if you add up angle A, just an angle, if you just only add up angle A and angle B, it's 90. Okay, now that you know that, let's do an example. So example says, find the angle of the measures. So we have this triangle, we have angle P that's 30, we have angle Q that's 25. We have this angle one and I don't know what that is, right? And then you have this angle R. What is angle one? So angle one is the sum. So yeah, angle one would be, so angle one is related to this exterior angle theorem. So if you add up, so there's two ways you can find angle one. You can add up angle P plus angle Q and set that to angle one, right? So you can say, we know angle P plus angle Q is going to equal to this angle one, because that is that we just talked about that theorem. That is the exterior angle theorem. So angle P is 30, angle Q is 25. That equals to angle one. 30 plus 25 is 55. 55 equals to angle one. Okay, what else do we know? Is there another way we could find angle one? Yeah, we can. we could figure out what angle this is, which is really simple because what did this of the interior angle add up to? 180. So you could say angle 30 plus 25 plus our unknown. Let's call it, it's not r, let's call it angle x. Adds up to 180. So that would be 5 plus x equals 180. Subtract 55. You get 125 degrees. So did you know this is 125 degrees? Now, I could find out what angle 1 is because this is supplementary because it forms a straight line. So you could say 125 plus angle 1 equals 180. Subtract 125. Angle 1 is going to be 55 degrees. Okay, so there's two ways you could have found angle 1. Okay, let's move on to 13. So in 13, M is parallel to angle N, angle 3 is 45, angle 6 is 100 degrees. Find angle 1, find angle 2, find angle 4, and find angle 5. Okay, so you have this image, you have this triangle, you have two parallel lines, and they say that angle, what did they tell us? Angle 3 is 45, angle 6 is 100. Okay, I would find, yeah, what do we know? What do we know? We know that angle 2 is congruent to angle 5. Where's 2? Why is angle 2 and angle congruent to angle 5? Alternate interior. And what else do we know? We know that angle 3 is congruent to angle 7. What would be the reason? Because of alternate interior. And we also know that angle 1 is equal to, where's angle 1? Angle 1 is equal to the sum of angle 3 and angle 6. Right? Okay, so we'll just have to use what we know. Well, I think I could find out what angle 2 is now immediately. How can I figure out angle 2 is? Well, if you add up 45 and angle 3 and angle 6, they all add up to 180, right? So you could say 45 plus 100 plus angle 2, they add up to 180. So that would be 145 plus angle 2 is 180. Subtract 145. 35. Okay, so angle 1 is going to be 35 degrees. Oops, no, that's angle 2. Could we figure out what angle 1 is? Yes, angle 1 is the sum of angle 3 and angle 6. So here's angle 3 and angle 6, so it's going to be 45 plus 100, which is 145 degrees. So angle 1 is 145. Can we figure out what angle 4 is? Yes, we can. So how would I find angle 4? Well, angle 3 and angle 4 forms a straight line, so they're supplementary, right? So you could say 45, because that's angle 3, plus angle 4, I'm not sure, adds up to 180 degrees. Subtract 45 degrees. So angle 4 is going to be 180 minus 45, which is 135. And then what do we know about angle 5? Uh, we said that angle 5 is congruent to angle 2. So angle 5 is now going to be 35 degrees. What about angle 7? Well, we said that angle 7 is congruent to angle 3. Do we know what angle 3 is? Yes, it is 45. Okay, now, yeah, there's other ways you could have done that. Remember, angle 1 and angle 2 are supplementary, so is angle 3 and angle 4 are supplementary. So is angle 5, 6, and 7. They add up to 180. So if you didn't know these rules, right, if you didn't know these theorems, you could have just say that a straight line forms up 180 degrees. Okay, let's move on to 14. Okay, 14, we have this triangle, right? We have this triangle and then this straight line. I got to figure out what angle A is. And yeah, so what can we say? Okay, so what do we know? I don't know what X is. I don't know what this angle is, but I do know that angle A plus angle B is equal to angle DBC. That's what I do know. DBC. What rule is this? Is the forget it. It is the ex exterior angle theorem, right? Exterior angle theorem. So angle A is 5x plus 4. Angle B, I don't know what angle B is. Hmm. Wait, what if I draw like another image, right? Angle 1, angle 2, angle 3. So if you know that we know that angle 1 plus angle 2 is equal to angle 3. So I got this wrong. It should be angle A plus angle D. So that is because of the I keep forgetting these rules. Your angle theorem rule. So the reason why angle 1 plus angle 2 is equal to angle 3 is because of that exterior angle theorem, right? So we could say that angle A plus angle D is equal to angle DBC, this angle 8x. So we know that angle x is 5x plus 4. We know that angle D is x plus 12. And we know that the angle DBC is 8x. Okay, so if you kind of clean this up, 5x plus 1x is 6x. 4 plus 12 is 16 equals 8x. And then subtract 6x, subtract 6x, you get 16 equals to 8x minus 6x is 2x. Divide this by 2, x equals 8. So now we can figure out what 8 angle A is because we know what x is, right? X is 8. So angle A is going to be 5 times x, or 5 times 8 plus 4, and that would be times 5 is 40 plus 4, that's 44. And now we can figure out what angle D is because it's x plus 12. So that is my x is 8 plus 12, which is 20. And now do we know what angle DBC is? DBC? Yes. DBC is 8x, which is going to be 8 times 8, which is 64. Can we figure out what angle ABD is? Where is it? B, D. So this unknown angle. Yes, we can because we know that angle A is 44 degrees. We know that angle D is 20 degrees. We'll call this x. So it's going to be 44 plus 20 plus x equals 180. That's 64 plus x equals 180. Subtract 64. X is 180 minus 64. That is 116. Okay. Yeah. So let's move on to two more examples. So in this example, it says find the angle measures. So it looks like these two triangles are congruent. Or are they congruent? I'm not sure. No, they're not. We're not sure that they're congruent. They look similar, but yeah. What we're gonna do is oh, it doesn't have any questions. Well, because I didn't write it. We got to find out what angle y is. We got to figure out what angle z is. We got to figure out what angle wxz is, and we got to figure out what angle zxy. Okay. What could we do? Uh, Angle y is this angle right here, right? I need to somehow figure out what n is. So what do we know? We know that maybe 5n plus 15 plus 6n minus 25 equals to angle x, right? And so let's do that. We know that 5n plus 15 plus 6n minus 25 equals angle x, which is 4n plus 60. And if you kind of clean this up, 5n plus 6n is 11n. 15 and negative 25 is negative 10. Then you have 4n plus 60. And then subtract 4n, 11 minus 4 is 7n. Minus 10 equals 60. Add 10, add 10. You get 7n equals 70. Divide this by 7, n equals to 10. Okay, now can we find out what angle y is? Yes, it's going to be 6 times n, 6 times 10 minus 25, which is 35 degrees. Can we figure out what angle z is? Well, yes, we can, because now we know what n is. Angle z is 5n plus 15, so that's 5 times 10 plus 15. That's 50 plus 15. That's 65. What about angle WXZ? Where are you? WXZ. Uh, The reason why you can't figure out what WXZ because I didn't put a W here, right? WXZ is this angle. Yes, we can. It's 4n plus 60, so it's 4 plus n, which is 10, plus 60, which is 100 degrees. Can we figure out what angle is ZXY? ZXY. Yes, we can. It's this angle. And we know that angle Z is 65 degrees. We know that angle Y is 35 degrees. So to find out this unknown angle, or we call it ZXY, ZXY, I'll call it, so we know that 65 plus 35 plus angle Z XY is equal to 180. So 65 plus 35 is 100 plus angle ZXY is equal to 180. Subtract 100. Angle ZXY is going to be 180 minus 100 degrees. Okay. Okay. That wraps it up for that one. Oh, the reason why I made this is because, yeah, these two triangles are the same. Okay, let's look at a proof. So question 16 says, complete the two-column proof. We are given that angle A is congruent to angle B, and we know that ray CD is parallel to the line segment AB. Prove that ray CD bisects angle ECB. Okay, so here's our image. We got to prove that ray CD bisects ECB. So what I would do in a two-statement, two-column proof is write down my given. So my first given was angle A is congruent to angle B. That's given. And what was also given? Ray CD is parallel to AB. Ray CD is parallel to AB. That's given. Okay, then what else could we say? We could say that angle 2 is congruent to angle A. So angle 2 is congruent to angle A. Why? Let me write that down. Angle 2 is congruent to angle A. Okay, so 2 angle. What would be the reason? The reason is because two parallel lines cut by a transversal line. Then that makes it, then corresponding angles are congruent. And corresponding angles okay. What else can we say? We can also say angle 3 or angle 1 is congruent to angle B. Here's 1, here's B. So these two angles are congruent. And the reason why is two parallel lines, same reason for statement 2. Two parallel lines are cut by a transversal, then alternate interior angles are congruent. Okay, what's more? Another reason, we could also say that angle one is congruent to angle two. So here's angle one. Angle one is congruent to angle two is because substitution property. And then last statement, we could say that ray CD bisects angle ECB. Ray CD bisects angle ECB. And the reason is definition of angle bisector. Okay, so that is the proof. We just proved that ray CD bisects ECB, and the last statement is the definition of an angle bisector. Okay, I am going to stop here, and for the next video should be about congruent figures. Okay, I will stop here. Thank you.